in this session, I will be showing you more of Visual Studio 2026, but I will be focusing more on the diagnostics part. I'll be sharing more of the improvements we have been doing around the debugger and profiling workspaces with the Copilot experiences. So to start with, my name is Harshada Hole. I'm a product manager in Visual Studio's debugging and profiling team. From last few months, I've been focusing on the Copilot experiences, but I've been in the team for almost 4+ years now. So super excited to be here and share all the new improvements we have been doing. I have a lot of demos packed today. So hopefully if the internet works fine and Copilot works fine, I should be able to share everything. Just to give you a recap, I'm going to be sharing some of the basics debugging features like breakpoints, tracepoints, and how you can use Copilot to make that experience a little better. Then we'll also see some of the data visualization while you debug. And again, some of the Copilot assistance there to see how you can actually make that data visualization more easier. Then I will be sharing one of our newest experience around inline variable values with Copilot assistance. And I will also talk a little bit about some of the newer capabilities we added in the exception helper. So exception helper has been one of our very first feature where we added Copilot assistance. And since then, we have been adding a lot of new capabilities there. So we added a deep analysis for complex exceptions as well as some repository context. So we'll see the demo around that. We'll also see a demo on how you can actually figure out when you have a deadlock or a hang situation when you're working with multi-threaded programming. And then finally, I will show you a debugger agent, which will actually help you fix your failed test. And then we will also try to see a Copilot profiler agent to see how you can optimize the code, which unfortunately we couldn't see in the keynote due to the internet issue. So I'll try to show you how I use the profiler agent to make my code faster or optimized. Okay, so let's get into the demo. So as I said, I will be starting from the basic features like breakpoints and tracepoints. For my very first demo, I'm going to be using this simple application called car list. It's just an application that gets the different details about the car, and at the end, it gives me all the details with discounted prices and adjusted prices. Now, if you notice here in the line 12, I am actually generating 300 cars. So I'm expecting that when I run this application, I should be able to see the details for all the 300 cars. So let's try to see that if it's working or not. Now, if you notice here, I have quite a few code here in this application and a couple of breakpoints too. So if I run this application, I'm going to stop at each of those breakpoints, which I don't want to do. What I can do is I can use something called force run to cursor. So what force run to cursor does, it actually runs your cursor at a particular line, but it skips all your breakpoints without you deleting or disabling them. And it also skips all of your first chance exceptions if anything occurs like that. All you need to do, if you're not in a debug mode, right click and do force run to cursor. And then it will run the cursor at that particular location, which for me, this is my application run. And it's showing me that the number of cards displayed is 266. So clearly there is a bug. I was expecting 300 cards there. So let's try to figure out what is going on here. I'm going to stop my debugging again here. Now I want to take your attention to this breakpoints window I have. So if you notice, I have these breakpoints arranged in certain types of groups. So this is using the breakpoint groups again. Breakpoint groups can be really handy when you are working with multiple bugs and you just wanted to focus on one particular section. You can disable, enable those breakpoints in a group with just single click. For me, my scenario is different types of demos. So right now I have a breakpoint group for a visualizer enabled here. Let me go to the code here. So if you notice, I have this breakpoint on line 42. This is where a generate car function is actually getting all the details and adding it to the list. So I'm going to go ahead and start my debugging and stop or break at this line 42 here. The reason I broke a break here is I wanted to see what all the data this list is creating. So to visualize the data while you're debugging, there are multiple ways you can do that. You can hover over this function. You can use this data type, which you all might know already. You can expand and see all the data inside it. Or what you can do is you can also hover over this view here and use something called IEnumerable visualizer if you don't know. So IEnumerable visualizer will actually show you a better way to visualize your data. Any type of IEnumerable, you can actually filter your data, sort your data, even export your data if you want to. Now, I only have 300 rows here, but imagine when you have a larger set, this could be really handy to filter sort. And you can even do custom filtration using LINQ queries here. So you can write your own LINQ query in this expression text box, and that will actually do a custom filtration for you. Now, if you need a little bit help with writing the LINQ queries, what you can do is you can go to this generate expression button here. If you need a little bit help with writing your LINQ queries, you can actually click on this. I already clicked, but you can click on this text box above the expression text box and actually describe your LINQ query. So right now, if you notice in this data, I'm seeing some of the cars which has negative price. My hypothesis is that might be an issue why I'm not seeing all the cars. So I want to know all the cars which have a negative price. I'm just going to go here and say, give all cars with negative price. And what Copilot will do is it will not just create a LINQ expression here, but it will also filter out. So this was a super simple example, but you get an idea that when you have a complex data set, you can write some complex query using that as well and do some custom filtration. So now we know we have some negative car price here. That might be an issue why we are not seeing all the cars. So let's continue our investigation further. What I'm going to do is I'm going to go here, disable my debugging, and I'm going to go ahead and use my different breakpoints for a different demo. I want to start my investigation from this adjust car price function. I'm actually adjusting the car price based on some discount and everything. So I want to start it here. I placed a breakpoint here on line 51. Now, if you notice, this particular function is called from the generate car as well. So I might be hitting this breakpoint 300 times, which I don't want to do. What I can do is I can convert this breakpoint to a conditional breakpoint. So with conditional breakpoint, this breakpoint will only hit at particular condition. For me, I want to see that the car price is negative. So what I can do is I can go right click on settings, go to conditions, and I can write my condition here. Again, you can write your own condition, but if you need a little bit help writing your conditions or just want to get some ideas around what other conditions might work, or if you're like me, you just forget about the syntax and you wanted to remember about the syntax, what you can do is you can just click here and Copilot will actually come up with some of the suggestions that might work here. Now, it's not exactly giving me the condition I wanted, but I'm just going to go ahead and do 0 because I want a price which is negative and I want this breakpoint to head to wherever the price is negative. Now, my breakpoint here is a conditional breakpoint. Now, this Copilot suggestions also works great with trace points, or some people call it log points. So trace points are something you can actually use to log certain type of information while you're debugging or while you're coding. And the best part, you don't have to remove that when you're pushing your changes to code. So you don't have any log messages or anything. So what I'm going to do is I'm going to convert this breakpoint on line 81. This is where all the prices, like the discounted prices, I'm adding like discount price, the age discount, very old discount price is added. So I want to see all those prices. So I'm going to log this particular information here using trace point. So again, go to settings, and to do a trace point, you go to actions. And then as soon as you place your cursor here, Copilot can actually come up with suggestions. For now, I'm just going to use my own statement here because I want all of the prices. So you'll see I have a trace point which is going to give me all the prices so I can quickly see what's going on. Now I'm going to start my debugging again, and what I'm expecting is that the breakpoint on line 51 will only hit if the price is negative, and this log point will actually tell me which particular price, which particular discounted price have an issue. So Let's try to see that. Okay, so you'll see the breakpoint on line 51 is it. I'm expecting that the price is negative, which is right. And I'm going to go in the output here, and you will see it also logged certain information about all the prices, and you will see this very old car discounted price is negative, and that might be the reason why we are getting our car price negative as well. My hypothesis is that I am actually doing some discounting logic here at the bottom. I'm adding some percentage discount to all these prices to adjust it. And maybe for the very old discount, I'm actually not using percentage on the whole dollar amount, and that might be an issue. But this was just a simple example to show you how you can use breakpoint, trace points, or even data visualizers to come up with or find your bugs a little easier. Now, before I go to the next demo, I want to show one thing quickly. I'm going to go back to my breakpoints again. Okay. So we saw a little bit around LINQ query. A lot of times we also have LINQ query in our code. So for example, I have again a super simple example to show you around a LINQ query which inside in my code. So we recently added something called a LINQ hover or a LINQ visualizer. So whenever you have a LINQ expression in your code, with the LINQ hover, what you can do is you can hover over that LINQ expression and you will see the filter data right there in the editor. Again, you have all the options. You can actually just view the data using IEnumerable visualizer and then make sure your data is correct. Or when you hover over the last part of the LINQ query, like the full LINQ query, you have an option to see the data filtered by the whole LINQ query. The best part, you can actually use the visualizers, but you also have an option to analyze with Copilot. So in case if your LINQ query is not working correctly or you are seeing a result which is unexpected, you can analyze that with the Copilot, and Copilot should be able to provide you some details around what's going on. So I'm not going to go there, but just wanted to show you that quick option where you can actually also analyze LINQ queries. So these were some of the examples around like basic features like breakpoint, trace points. Now I wanted to show you something which we recently added, and that is inline variable values. So for this, I'm going to be using, let me go back to program here. Okay. I am going to be using another application. It is called an IoT monitoring system. It is a simple application that actually monitors the sensor temperature to check if it's right and if it's on the right location. Now, this is my output. You will see I have an average temperature of 22.76. And then some of my sensors, which actually has a correct temperature range, like around 22, 23, and are in a correct location as well, are flagged as anomaly, while my test sensors are flagged as normal. So another clear bug here. So let's try to figure out what's going on. Before I go to the demo, I want to ask you, how many of you actually create or have created temporary variables to track down the return values or the functions which the return values which are creating? So I used to do that too, but now with the inline values, you don't need to do it. So let's go back to the code here. Let's start my debugging again. So before I go to the bug, I want to show you, I have this breakpoint on line 30, and you'll see it has a function call for get sensor reading. I don't have any breakpoints in there. Now, if I want to see a returning value for this function, all I want to do is start my debugging, break on that line, step over, and you should be able to see what that particular function is returning right there in the editor. The best part, if this is a complex object, you will have all the capabilities for the data types. So you can expand it, visualize your data, and see if the data is correct or not. And it also has analyze with Copilot again, in case if you need to. Now, coming to our bug, we saw like some of my correct sensors were flagged as anomaly and the test sensors were flagged as normal. I have this breakpoint on line 21 here. This is an if statement where it's checking if the temperature is correct or the location is correct. I'm going to go ahead and enable it and continue my debugging here. And I want to take your attention here again. For this for each loop, you will now see the data here in the editor again. And because it's a complex object again, you should be able to pin your data which you wanted to see or like which you're interested. For me, the location and temperature is something which I was interested. So I pin my data here. So it's super easy to see when you're going through that loop. You don't need to hover your cursor anywhere. You're just able to see the data right there in the editor as you're debugging. Another thing I wanted to take your attention is this if statement. You will also see an if condition evaluation right there in the editor as well. So you'll see, for me, for this particular scenario, the server room A with temperature 22 is giving true, which is again a bug. But with this, you actually can just see what the if statement is returning right there in the editor. You don't have to hover over or go and figure out what's the evaluation is. Now, we saw that this is giving true. That means something is going either in the isAnomaly function or isLocation. I'm going to start my investigation with this isAnomaly. Just going to go to the definition here. I'm going to enable my breakpoint here. Continuing my debugging, one more thing I wanted to show you is that you can also see the inline values for your function parameters. Again, we were able to see that this particular isAnomaly has the temperature, the value of the temperature and the baseline. Again, a super handy way to see your data while you're debugging. Now, if I step over it, you will see you are also seeing the return value here in the inline, so you don't have to create those temporary variables anymore and delete them later or forget to delete them later. And you will not just see the return value, but you'll also see a returning value here. Now, for the temperature 22, I am getting the isAnomaly true. That means something is wrong here. As I gave you a little bit hint there that all of these inline variable values has Copilot assistance with it. What you can do is, for me, this particular value is not something I'm expecting. So I'm going to go ahead and actually click on Analyze with Copilot here. And actually, Copilot will tell me why I'm seeing the value I'm seeing or why it is coming up true. So just going to confirm here. Also, I forgot to give a warning before. Sometimes Copilot work as expect, or sometimes it just have its own mind. So it's a live demo. I'm expecting that it should work. However, I practiced in my demos, but if not, that's Copilot's fault. But you'll see here, it's actually telling me that I am using this comparisons wrong. I should be using it greater than baseline while I'm using the less than baseline. So super simple example, super simple mistake here, but you saw with Copilot, you were able to find that pretty quickly again. Now, if you are one of those who actually likes to use your autos windows or locals windows or watch windows, you also have a Copilot assistance in there as well. So in case if you're seeing any value in your autos watch windows, which is unexpected, you can actually use this Analyze with Copilot button from those windows or even data tips to see why you're seeing the value you're seeing, or if you're just going in a newer code or a code you haven't touched in a while and you wanted to understand the code, in that scenarios as well, this is super helpful to know why you're seeing those variable values. So this was inline variable values. Now I'm gonna go to my next demo. I'm gonna stop my debugging. So as I said in the starting that exception assistance is one of our very first feature, where we added Copilot assistance. But you all know exceptions can be various types. It can be a simple exception, nested exception, very complex exception as well. So we have been adding a lot of improvements and providing a lot of context to the exception assistant to make sure we get accurate responses, and it works on its own whenever it needs to do a deeper analysis or just wanted to provide you a quick immediate fix. I'm going to be showing you 3 examples today. One is a very simple example where Copilot comes up with an immediate fix. We'll see another example where Copilot takes a little bit more time, does a deeper analysis, and then come up with a fix. And then the third example is where we are actually providing a repository context. So the repository you have open in your Visual Studio while you are working with Exception Helper, and then it comes up with some context related to that. So my very first demo, I'm going to be using this serialization example. Just going to go ahead and execute this particular program here. And you will notice the very first thing I get is this exception. It is telling me that response status code does not indicate, which is something else, which I wasn't expecting, but that's fine. This is Copilot. But okay, so this is a simple example here, which is telling me something is wrong with my HTTP request exception. So what I can do is, I'm going to go ahead and, okay, is click on Analyze with Copilot. And with what Copilot will do here is gather all the necessary information. And because we are actually directly clicking Analyze with Copilot from the exception helper, we don't need to provide any additional context. It has all the context it needs to. If it needs to, it gathers more context and then comes up with a immediate fix or deeper analysis. So this one particularly, I'm going to execute that again to see if it works as expect. So, okay, this is perfect. I don't know what happened there, but this is the exception I was expecting. Deserialization resulted in an empty object. So this is a simple exception. We get it a lot of time when you're doing deserialization. Again, I'm using a default model here and going to go with Analyze with Copilot. As I was saying, because we're clicking directly from here, it has all the context related to it, and it might gather more context as needed. For the simple exceptions, a lot of times what Copilot does, it comes up with a lot of confirmations, but it comes up with an immediate fix as well. So it's telling me that the root cause here is the API has a root object property, which is an array, and I'm actually assigning it to a list. So this, just wanted to give you a quick example. Like this was a very simple exception, and Copilot was able to come up with an immediate fix. Sometimes there are exceptions which are not that simple as it is, and even Copilot needs a little bit time or more analysis to do that. I'm not going to go ahead and apply this change, but this was just a quick show. And now let's go to another exception where we'll see how Copilot actually comes up or needs a deeper analysis. So I'm going to execute another exception here. So you'll see I have an exception that is saying nullable object must have a value. Now my object is func1 here. If you notice in my autos window, I'm actually assigning a null to an integer type of func1. That might be an issue as well because it's an integer type and I'm assigning null. To be very honest, I know this code, so I know that this particular func1 does not need to have null. It's actually having more than, it has a value, and the result is more than 10. So I'm just going to go ahead and try to investigate what is happening. I'm going to go into this func1 and see from where this is called. So go to definition, and you'll see this func1 is actually called from func2. And I'm guessing the func2 must be called from func3 and then so on. This is a very common structure we can have in our production level code as well, like one function is called from another. And if there is an exception in one of those deeper function chain, it might take a long time to investigate that. I'm going to try this investigation using Copilot here. We saw that for previous exception helper example, I used the default model. We actually implemented some improvements recently, so you can actually also use other model, not just the premium model, but not just the standard model, but premium model or whatever favorite model you have for your exception helper as well. So I'm going to go ahead with Sonnet 4 here and click on Analyze with Copilot. So as I said, Copilot has all the context from here, and it will try to gather all the context and try to do some investigation at the start. We do need to ask a confirmation a lot of times to make sure that users know what Copilot is doing. and we are not changing anything without your permission. So a lot of times you will see, in some cases, it's more confirmation. Some cases, it doesn't need that many. Okay, so it came up with a hypothesis, and it's trying to find why the system the label value we are seeing, and it's still doing its investigation there. And you'll see it is also trying some other approaches to find out the root cause. So this is what I wanted to show you, that Copilot did its initial investigation. It came up with the hypothesis that func1 is an internal class. And then it also asked me if I wanted to go deeper down to see so this is an immediate fix, but it also asked me that if I want to go deeper down to see what might be causing it. I'm just going to go ahead and do yes and see what Copilot comes up with here. So it's going down to the whole chain. I think I only showed till func2 or func3, but it's more nested than those three functions. It's at func9 right now. Sorry. Okay. And then after going to the 15th iteration, it actually came up with a root cause that in func15 there is an issue. So as I said, I just wanted to show you an example where, like, I think the 15th not a number is a problem here. But just wanted to show you an example that Copilot actually, or exception helper, figured it out where it needs to do a deeper analysis or where it needs to just come up with an immediate fix. So this deeper analysis is actually very helpful when you have these nested kind of exceptions. You have a question?
Yeah, just real quick, when it's doing all the analysis and trying to look and figure out what's going on, is that Copilot piece privatized to the code base that you have, or is that something that's now publicly accessible?
No, it is related to the code base I have. So the exception I had is that nested. I had 15 functions there, which is having an issue. Is that your question?
Well, no, I'm just saying, like, when Copilot analyzes it, does that make your source code then accessible to Copilot to learn traffic?
Yes, we are providing the context to that. So the third example I wanted to show you is we saw two examples, like a simple exception and a nested exception. This might be related to your question too. Like, we added something called a repository context to the exception helper. So the repository you have open, the Copilot will actually use the context related to that, your open pull request, your bugs, similar types of bugs, the issue you're seeing, or similar bugs or issues which are fixed related to that. And then it will come up with a solution related to the exception you're seeing. It might be a little closer to what your team structure is because it's using a repository context. But even with that, it is not publicly available. It is still within the Visual Studio, or the context related needed for the Copilot will be still for that particular session only. This demo, I'm going to be showing a recorded version. It's a little difficult to show the demo with a repository context with PII issue. So hopefully we should get the audio.
Today I'm going to demonstrate some improvements we've made to the debugger's exception analysis with Copilot feature in Visual Studio. To start, I have a solution open and I've run into an exception. I've been doing some development in VS and I'm working on persisting options for some new features, and I've noticed that it's not working. So I've run into this exception, and I'm not really sure what's going on, other than the call to say package user options seems to be failing. To start, let's run through the automated analysis. I haven't enabled our new features yet, so we can see what it looks like in the current state. Let's start the analysis and let Copilot start thinking. This will go through and use many of the tools it already has, like accessing files, evaluating variables, or checking the debug output to come up with some idea of what might be wrong. Now, we can see that this is providing us with some ideas of what to look at, but it's not providing an exact solution. We'd need to do a little bit more investigation to figure out what the root cause could be. We could continue in this conversation, but I'm going to change options now to show the new features would allow us to do. We go to our options for Visual Studio, and we can enable this, which would be on by default, but was off for this demo, and we can turn on our new feature, which allows adding repo context to the exception analysis, and if we rerun the analysis now, we can see what differences we get. While this runs, I'll note that what this is going to end up doing is looking at the repo we currently have open and use that as a way to search for existing bugs, issues, pull requests, and incorporate them into the context of what we use to analyze this exception. So this will run through, it'll ask permission to ask for access ADO content, and it will start looking for anything relevant. It's decided it wants to ask with different search terms, so I'm going to always allow so it doesn't need to ask again. Now it's come to a conclusion, and we can see that it's giving a very different answer. We can see it's provided some specific information about what this H result is and what the likely problem is. Our name seems to be too long, and if we look closely, we can see it's referencing some bugs that have data about this. We can also use those to find more information about what other folks have run into and how they've fixed this or similar issues.
So we saw like how when we provide more context to Copilot with the repository, it can actually come up with a solution which is more closer to your repository or your team structures or your team styles of writing code. It also provides you similar issues which are fixed recently. So you have the code which is not completely different, but it is related to what you have been fixing before as well. So these were some of the examples related to exception helper. Now I want to show you how you can actually investigate when you have a hang situation or you have a deadlock situation when you're dealing with multi-thread application. So let me go to a different project here. For this, I'm going to be using a application called stock market where different cats for some reason are trying to do some trading. So let's try to, I'm going to start this application and see what happens. You'll see they're just trying to sell and buy some stuff here. And at some point, this particular application is going to hang and nothing is going to happen. So I think we're at that situation now. We're not going further. It's just hanged here and it's not working. What I'm going to do is I'm going to do break all. So I break on all the threads and that will help me find out what's going on. As soon as I do break all, you will see similar to exception helper, I actually see a dialog which is telling me that a deadlock is detected and it provides me some little information here. It has a couple ways you can actually go ahead from this dialog and try to investigate. It has an analyze with Copilot option and also a show parallel stack option. I'm going to go to the show parallel stacks option first. So if you have never used parallel stacks before, this is super handy tool when you deal with multi-threaded programming. It gives you this graphical view of your threads. So it's easy to see what's going on and easy to understand. Now in this thread, there are a couple ways that could be helpful to find out what is going on. First of all, you'll see these icons, which actually right away telling me that which particular threads are deadlocked. It gives me the warning as well. At each of the thread, you will also notice that this sparkle button, which is actually a Copilot insight, it actually gives me a summary of that thread. So again, this is a simple example. When you have a huge thread, it will actually give this, the summary of all the stacks. So you don't have to go manually do and find out what is going on. For example, for this worker thread, it is telling me that deadlock is waiting for a lock. Let me go and see another example. For this particular thread, it is telling me that waiting for the data from the network pipe. So it's easy to see this summary and understand what that particular stack is doing. Another way here could be helpful to understand this particular hang situation is this generate insight button. So what this generate insight button does, when I click on it, Copilot actually gives me a summary of what's going on, why I'm seeing this hang, or what I'm seeing this in particular diagram. It gives me the details on what particular thread is deadlocked or who's waiting on which particular log. And it also gives me some steps to investigate further. So again, it is very easy way to understand this diagram if you're not very familiar with it, to see what is going on particularly in that diagram. Now going back to I'm going to close this, to this deadlock detected here. Similar to our previous example, we also have this analyze with Copilot option here. Once I click it, Copilot has all the context of this hang situation or the deadlock situation, and then it actually comes up with a summary of what's going on, gives you an initial data on or initial information of what is happening, and then actually it's asking me if you want to suggest a lock ordering strategy to prevent this deadlock. I'm just going to go ahead and do yes. And then Copilot will work with you to figure out what is happening or how you can resolve this particular deadlock. It actually came up with a code which is helping me to resolve this lock situation. I'm not going to apply this, but just wanted to show you that when you have these logs or hang situation, having a little bit assistant could really help you move it a little faster, because even with the parallel stacks diagram, it can be sometimes overwhelming to understand when you have a lot of threads. So this was parallel stacks and multi-threaded programming and how you can use Copilot to understand it a little better. So we saw a lot of examples so far where we saw, I'm going to go ahead, I'm clicking, I'm going to give more instructions to Copilot, or I'm actually confirming a lot of stuff. So I am actually working with Copilot in that particular scenarios. I wanted to show you two scenarios here, with one is the debugger agent and another is the profiler agent, where the agent takes a driver's seat. It still asks you for the confirmations where needed, but it actually does everything. So you actually just have to wait and analyze and actually just review what the agent is doing. So for the first debugger agent, we recently added this functionality where you can use an agent to fix your failed test, which is single click. So failed test is again very common. Most of us, or every one of us actually has a failed test. I'm going to go ahead to go and set up my startup project, and going to go here in the text explorer, just going to run it again. And you'll see all of my tests here are failed. So I'm going to try to see if I can actually fix one of those using Copilot. So what you need to do is on your fail test, you just need to do right click and do debug with Copilot. When I say debug with Copilot, it is not just going to go and fix it and give me the solution. It will actually show me detailed steps in the chat. It will actually start a new debugging session, place some breakpoints if needed, and give me the step-by-step instructions in the chat too, so I know what the debugger agent is doing too, so I can even learn from that as well. When I click on the debug with Copilot, you will see in this chat here, it is getting the context it needs to, and then it starts working. You'll see it's actually setting some temporary breakpoints and starting a new debugging session here. And it will come up with the initial hypothesis and propose a fix. It will go ahead and apply the fix as well as it's an agent, and then rerun the test. Sometimes, as even when we work, like sometimes we apply a fix and then it still does not work. In case if it happens in this scenario, like Copilot come up with that immediate fix, applied it, and it actually failed, that particular fix is failed and the test is not passed, the agent will actually make sure that it comes up to the root cause until and unless the test is passed. So it will go ahead, come up with a correct fix, and make sure that the test is passing. So it's come up with another hypothesis, and it's actually validating. And let me go back to my text explorer, and you will see it also reran the test to show you that the test is passed. I'm just going to go ahead and rerun it again to make sure it passed correctly. And you saw just with single click, we were able to fix this test using the Debugger agent. Now, as I said, it just did not give me the fix, or it just did not give the correct test. It gave me all the details in this chat. It is telling me how that the breakpoints are set, the debugger session is started. It removes all the breakpoints after it is done fixing the test as well. And as well. So it's a pretty good experience to work with your failed test. You're just not just getting the fix, but you're also learning how to fix it. So this was the Debugger Agent on how you can actually fix your failed test using the Debugger Agent. Now I wanted to show you something called Performance Profiling Agent. So a lot of people, or not everyone, is a performance expert, and that is exactly why we actually created a performance profiler agent. We wanted to make sure that anyone can actually optimize their code, not just when you see a code is slow. You can actually optimize your code anytime when you have a newer feature completed, or you're just touching a code which is super old, or your code is really slow. And to make that easy, we created a performance profiler agent. So it's super easy for anyone to just go and point the agent to the code and ask, help me optimize this code. So unfortunately, we couldn't show the demo in the keynote today with the internet issue, but we have been actually using our performance profiler agent on the top 100 open source libraries to make sure the agent doesn't work on the toy application like I have, but it also works on all the production level application as well. And we were able to actually come up with the fixes on many libraries and actually submitted the PRs. And all those insights were completely driven using the performance profiler agent. For the demo today, I'm going to be showing a application which I just created a couple days back. And I want to make sure that it is working fine, and just wanted to show you how the profiler agent works. I have this application called Grocery Store, which is just managing some inventory in the grocery. There are a couple of ways actually you can invoke a performance profiler agent. You can just go to a Copilot chat. So as I was saying, there are multiple ways you can actually invoke a performance profiler agent. You can go to your Copilot chat and you can just do @profiler and ask a specific question related to profiler agent. Ask a specific question related to your performance or your optimization or memory allocation or related to your code. Or if you don't have a specific question, you can just go to an agent mode and start asking any questions related to optimization as well. Now, there is another way you can actually invoke a performance profiler. So if you are a regular user of profiling tools, if you have used our existing performance profiling tools in Visual Studio, you also have, I just want to show you this new experience here, that this launch page actually gives you all the details about what particular tool you can use. And you can see you have some flexible tools, standalone tool, and you also have this recommendation here where you can actually use a particular tool. If you don't know which one to use, it will actually give you a recommendation as well. I'm using a different version, but what I wanted to show you is that if you're a regular user of this particular launch page, you also have an option to invoke a performance profiler from here, which you can't see it, but you should be able to see that very soon in Visual Studio's latest version. So you have a couple of ways there. Or if you don't know anything about your performance profiling, you just wanted to try it out, another super easy way is to just go to this icebreaker here and say, suggest how I can optimize my code. So just before I click on this, I wanted to tell you how the profiler agent work is we're just not going and fixing your code and making it faster. We're also making sure that we are actually measuring it using benchmark.net benchmarks. So the profiler agent will actually make sure your code has a performance benchmark.net benchmark. If it doesn't have that, it will create a new suite for you and it will create related benchmark. Then it will make sure it runs the CPU profiling tool or .NET allocation tool based on the question you ask, and actually run those benchmark for that particular insights which the tools give you to have a baseline. then the profiler agent will actually come up with a solution and run those benchmark again to see how much we improved. So we are not just getting the code fix there or the performance improvement there, but we are also seeing the improvement right there in the editor or in your Visual Studio. So right now I'm just going to go ahead and ask a very generic question to the agent that suggests how I can optimize my code. I don't know anything about performance profiling, and here what the agent will actually guide me through it. So what the agent is telling me here that I'm going to go ahead and run the profiler, analyze your code CPU usage, and then summarize the profiler results by suggesting targeted optimization based on your findings. And it's asking me, should I go ahead? I'm just going to go say yes. And then the profiler agent will run the profiler first to come up with some of the insights. This uses the existing profiling tool we have. So the agent uses the existing tools like CPU usage tool, a .NET allocation tool, or memory usage tool to come up with the insights. So I have a very small application here, but if you have a larger application, you need to go ahead and stop your collection after you execute the particular performance issue. Because this is a super simple application, it just ran completely here and I didn't need to stop it. You'll see here it actually came up with some top functions, top inside, which this is a very generic view which you normally get even without a profiler agent. And in the chat here, it is telling me that it gathered some insights based and actually identified some of the issues which are there in the store management program main function. And it is actually providing me two options, actually optimize the program main for the better startup performance, or investigate and optimize the loops. For now, I'm just going to go ahead with the first one and see what the profiler agent gives me. So it is gathering all the necessary context it needs to. Yes, it's asking me if I can create the benchmarks, which we can surely do. So as I said, if it will try to find the benchmark, if your code has it, if it has existingly, if it doesn't have, it will actually go ahead and create a new benchmark code it hasn't created yet. So it's gonna, the step one was to locate the issue or the insight, and then the step two is to create a benchmark for the program. I'm just gonna go ahead and do yes. So it will create a new benchmark suite as my current application doesn't have, and you'll see right here in the Solution Explorer, it created a benchmark suite, it added needed dependencies. It will resolve if there are any issue, make sure the build is correct and the build is successful to go further. So it's creating the benchmark now. Running benchmark sometimes can take a couple of seconds. I think that's the only step normally that takes a little while. You'll also see the code the agent changed in the editor here. You don't have to click kip. I think it does on its own, but you still have an option in case if you wanted to revise it. Okay, so it ran the benchmark based on the existing code, and it is telling me that the mean is 1.2. And now what it is telling me that next I will proceed with the optimization. So the insights which we saw in the start with the CPU usage tool, it will apply that insight and run this benchmark again to see how much improvement we have been doing in this create store method. So I'm going to go ahead and do yes here to apply the optimizations. So it's going to go ahead and apply fixes or the optimization to make sure the code is faster. Okay, and now the mean is 874.8 milliseconds. That means it actually improved a little bit, 1.2 microseconds, which is not a great improvement yet, but still we have something. A lot of times the improvement which we see with the profiler agent also depends on certain scenarios, like like it can get affected by some external factors as well if I'm connected to my power card, if I'm running multiple programs, because it's a CPU usage. But this gives you an idea on how you can actually use a profiler agent to just understand more about your code's performance. Or if you don't know anything about performance, it just gives you a way to learn more about your performance and actually just optimize your code. Again, you don't have to be an expert to run the profiler agent, and you don't have to wait for a particular scenario when the code is really, really slow and then go and run it. You can run it anytime because it's super simple to run it. You can run it when you have a new code, when you can run it when you just finished your feature, and or just whenever you're trying to push your changes to the PR. Those were all the demos I had today. Thank you so much.